Very good morning to all of you. I am Dr. Neetu Gahlot. I am working as assistant professor in St. Andrews Institute of Technology and Management, Gurgaon. I am from Applied Science Department and my subject is chemistry. And today I deliver my 21st lecture, and the topic of this lecture is a Schrodinger wave equation, and that is a part of the atomic structure. So now we are going to start our today's lecture, that is the atomic structure, and the main topic is the Schrodinger equation. And here one important point that the derivation of the Schrodinger equation is excluded in our syllabus. So we do not prepare the derivation of the Schrodinger equation. Here is the only introduction and the concept of the Schrodinger equation. Okay. So before going to the Schrodinger equation, there is the some important terms or some important mechanics, or we can say these are the theories, which is uh, required to know. We know about that. So, firstly, the word is the quantum mechanics. Okay, and we know that mechanics means that satisfactorily explain the properties associated with the movement of small particles like the atom, like the molecules. So this is called the quantum mechanics, or we can say it is the wave mechanics. So here, according they are the start first theory, that is called the classical mechanics. So according to the classical mechanics, the electron have as a wave or as a particle. So these two are the separate phenomena. या तो हम कहते हैं कि electron is behave as a wave, or we can say that the electron is behave as a particle. So both are the separate phenomena. So here the difference between the classical mechanics and the quantum mechanics. So firstly, we goes to the uh, according to the Einstein and the de Broglie. So when we say that the electron, uh, if the particle, if a electron, a moving electron has a dual nature, or here it means that it can behave as the wave, or it can behave as a particle. So if it behave as a particle, so that the energy is equal to mc square, and for the if the wave the wave, so it means the is equal to h nu, and we know h is equal is the sorry lambda is equal to h upon p. So here we know the all terms. M is equal to mass of the electron, is the velocity of electron, h is the Planck constant, and lambda is equal to the wavelength. So here we find that h nu is equal to mc square, and nu is equal to c by lambda. So that we found that lambda is equal to h upon mc. For any particle moving with the velocity v, then it becomes lambda is equal to h upon mv, and it is the h upon p. Mv is equal to p, it is a moment. And so the above equation, in the above equation, the lambda is called the de Broglie wavelength. So here one important thing, that what is the difference between the classical mechanics and the quantum mechanics. So there is some points at according to the classical mechanics, that it is appreciable at the macroscopic particle, and the quantum mechanics, it is appreciable to the applicable to the microscopic particles. Okay, so classical mechanics applicable for macroscopic particle, and the quantum mechanics is applicable for the microscopic particles. Then in the classical mechanics, the Newton's law are the fundamental principle of which it is based, and quantum mechanics, here the Heisenberg uncertainty principle and the de Broglie concepts of the dual nature of the matter are the fundamentals. Now the third point is that the state of a system is defined with certainty, and in the quantum mechanics, it provides the possibilities of finding the particle at the different location of the space. So these are the main difference between the classical and the quantum mechanics. So here one thing that we know about the quantum mechanics or the wave mechanics. So this branch, the branch of science, here the based on the Newton's law of motion and the Maxwell electromagnetic wave function wave theory. So they employed for the explaining the phenomena connected with motion and the energy. So it is known as the classical mechanics. Okay, and the classical concepts are not valid in the region of atomic dimensions. Okay, then in the microscopic world of atom and molecules, the energy and movement do not have the same meaning as in the case of the classical dynamic. So here the Schrodinger combined the idea of dual nature of a microscopic object in motion given by de Broglie and the Heisenberg principle of uncertainty, and put forward a three-dimension wave mechanical model of the of an atom. So this is the Schrodinger model. So here's the requirement of the Schrodinger model. So now the quantum mechanics or the in the wave mechanics, there is a no distinction between wave and the particle. The system is described by the mathematical function that is called the wave function, and we know that wave. What is the wave function? So here the it is represented by the psi, that is psi is psi, and it is called the wave function of the state of the system. And the psi with respect to the r and the t. So here r means that these are the x y z x along the axis of x and x y and the z, and the t for the time. So Schrodinger wave equation are the two equations in which the one is the time independent equation and another is the time dependent equation. So here we will discussing about the time independent equation. Okay, so the name of the Schrodinger is the Arvind Schrodinger, and this equation is uh, uh, according to their name, that is called the Schrodinger wave equation. So Schrodinger derived a second order differential equation for a wave motion of electrons, and the wave propagating in three dimension. These dimension are the, it means the x, y and the z in the space. भाई हम लोग कहते हैं कि according to the Bohr theory or the other theories, that the electron move in rotate in their in their class. ओके, तो वो अपने क्लास में ही रोटेट करता रहता है। तो अगर यही चीज सेम है, बट ऐसा नहीं है कि वो उसके जो ऑर्बिटल्स की शेप है वो सबकी अलग अलग होती है। इसका अगर ऐसा तो एस पी एस ऑर्बिटल राउंड शेप है, स्फेरिकल शेप है, पी ऑर्बिटल डम्बल शेप है, एंड डी ऑर्बिटल एज अ डबल डम्बल शेप। सो देयर इज द फाइंडिंग ऑफ द इलेक्ट्रॉन, वो कहीं भी प्रेजेंट हो सकता है, एक्सिस पे अलोंग भी हो सकता है। तो दिस इज इम्पॉसिबल, मतलब राइट नाउ पॉसिबल, बट पहले ये चीज़ मुश्किल थी कि उसको कैसे हम डिफाइन करें कि इलेक्ट्रॉन कहाँ है। And there is a not the talk about the one electron, it is the probability of the finding the electrons. So so now the equation can be written in the many forms, and the simplest form of the equation is given here. This is the uh, that is the d square psi upon dx square plus d square psi upon dy square and plus d square psi upon dz square plus 8 pi square m upon h square, and e minus v psi is equal to 0. So this equation is called the Schrodinger wave equation, and it is the time independent Schrodinger wave equation. Here the capital E is denote the total energy of the electron. So total energy of the electron means there are the both type of the energy, that is the kinetic energy and the potential energy. Now V is represent the potential energy of the electron, that is work done against the attractive force when the electrons move away from the nucleus. Okay, then the M is represent the mass of the electron, and H is the Planck constant. Okay, now the word the psi is called the wave function, and is the amplitude of the magnetic wave. Okay, so psi is the wave function, or it is the amplitude of the magnetic wave. So the above equation, that means the Schrodinger equation, can also be expressed as just like here, and here we can that the v square is equal to d square upon dx square plus d square upon dy square plus d square upon dz square. So these are called the Laplacian operator. Okay, so this is these are the basic concept of the Schrodinger wave equation, or now we know the what is the Schrodinger equation and why it is required. And now here the some values of psi are acceptable and valid, which satisfy some points are here. So these points in these points are here. The one is the first point is the psi should be single value. Okay, then the second point is that psi must be continuous. That is, there must not exist any sudden change in psi at the variables are changed. Okay. Then the third point is the psi must be zero at infinity. Then the psi must be normalized, and then it must be finite over the space d2, that is a very small space that the electron occupy. ओके बहुत छोटा सा पार्ट है मतलब along the axis xyz, so that the electron occupy. So these significant values of psi are called the eigen function. So we get the scientific values of the total energy of electron. So is there are called the eigen values. So here is a uh, here we can see that h psi is equal to E psi. So here the capital E is represent the eigenvalue, and the psi is the eigenfunction, and the h is the Hamiltonian operator. So these are the various values of psi which have been derived from the wave equation and corresponding the definite value of energy. So this is called the eigenvalue and are called eigenfunction. Okay, so here we know that the wave function of an electron, which is we call the psi, in the field of nucleus of an atom is called the atomic orbital, and it is a three-dimensional amplitude of the electron wave. And here the psi square, and here the two terms, that is the psi and the psi square. So psi is the wave function and psi square is the probability of finding the electrons in the small volume element dv surrounding the nucleus of an atom. So the particular value of the psi are called the eigen functions, and the value of energies which correspond of these are called the eigen values. Okay, so then this is the psi and the psi square, and here the psi itself has not significance. It simplify the it simplify represent the amplitude of the wave, but the psi square give the probability of finding the electrons around the nucleus at any point. So here that is the psi and the psi square. So now we know that the psi has not its significance, and it simplify the represent of the amplitude of the wave. ओके, जब हम देख रहे हैं ना कि वेव आ रही है कोई, तो वेव का मतलब ऊपर से नीचे की तरफ जब वो आ रही है, तो दैट द डिफरेंस इज कॉल्ड द एम्पलीट्यूड, कि कितना उसमें गैप आ रहा है. सो द psi square क्या है, it and the psi square, it gives the probability of, so this is the psi and the psi square, and the psi square gives the probability of finding the electrons around the nucleus at any point. So in this today we have discussed about the some topics in which firstly we talk about the quantum mechanics. So what is the quantum mechanics and requirement of the quantum mechanics. तो फर्स्टली हम लोग क्या देखते हैं कि जब कोई हमने कोई भी हम कुछ पार्टिकल फेंक आए, तो इट शोज दैट अगर वो मूव कर रहा है तो इट मीन्स इट फॉर्म्स द वेव्स, है ना। तो वो या तो ड्यूल करेक्टर शो करता है, या तो वो वेव है और या फिर वो पार्टिकल है। सो हेयर वी नो दैट अगर वो वेव है, अगर द पार्टिकल इज सॉरी, इफ इलेक्ट्रॉन इज behave like a wave, so it means the E is equal to h nu, and we know that the E is equal to E is the energy and is equal to the h is the Planck constant, and nu is the velocity. And here the if the it will behave as a particle, so that means the E is equal to mc square, and here the m is equal to mass of the electron, and c is the velocity. So there the equation between the first and the two. So we found that the lambda is equal to h upon mc, and here we know that lambda is the wavelength. Okay, so the for any particle moving with velocity v, so the equation becomes the lambda is equal to h upon mv, and it is the h upon p. So we know now all the things about the atomic structure. And here the one special thing, one important point, that is the difference between the classical and the here the difference, हम लोग क्या difference देख रहे हैं कि difference between the difference between the classical mechanics and the quantum mechanics. And the difference is the it is applicable, the classical mechanics is applicable to the macroscopic particles, and quantum mechanics for the microscopic particles. In the classical mechanics is based upon the Newton's law. The Newton's law is the fundamental base of this theory. And in the according to the Heisenberg here the in the quantum mechanics there are the Heisenberg uncertainty principle and the de Broglie concept of the dual nature. These are the fundamental. Now the third step is the state of the system is defined with certainly, and here we find the probability of finding the electrons in the space. So these are the difference. And then we find the quantum mechanics or the wave mechanics here, the requirement of the Schrodinger wave equation. So Schrodinger, the name of the is the scientist, that is the Erwin Schrodinger. So here in the Schrodinger equation we हम उस इलेक्ट्रॉन कहाँ मूव है, कहाँ पे उसकी प्रोबेबिलिटी है, तो किसी भी एक्सिस के अलोंग भी हो सकती है, वो कहीं भी है, तो नाउ वी कैन calculate this. So this is the Schrodinger wave equation, and the Schrodinger wave equation is in our syllabus. There is a no derivation of Schrodinger equation. So here is only the introduction and the concept of the Schrodinger equation. So the Schrodinger equation is the d square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square plus 8 pi square m upon h square, and h e minus v, and psi minus v, psi is equal to 0. So it is the time independent Schrodinger equation. We have already discussed the terms. E is the total energy, v is the potential energy, and m is the mass of the electron, and h is the, everybody know the h is the Planck constant. So here and the one important point, that is the psi, and that is the wave function, and is the wave function is the amplitude of the electromagnetic wave. Okay, so here we find that the if we can represent the d square upon dx square plus d square upon dy square plus d square upon dz square is equal to the v square, so that that is these are called the Laplacian operator. Right? Then we come to the some values, acceptable values of the psi, or we can say that the valid which satisfy that these are the psi should be the single value, the psi must be the continuous, and there must not exist any sudden change in the psi at the variable of the change. The psi must be zero at infinity, and psi must be normalized. It must be finite over the space dito that the electron occupy. So these are the one terms again here, that is the h psi is equal to e psi. So here the e is the eigenvalue, psi is the eigen function, and h is the Hamiltonian operator. And here according to the derivation, equation of the Schrodinger wave equation. So the equation represent the motion of a satisfactory value wave in the one direction, and say along that it is the x-axis. It is clear from this equation that for the stationary wave in the stretched string, the amplitude function psi and can have the significance value for the certain definite values of the wavelength lambda. So the wavelength is replaced to the total energy and is equal to hc upon lambda. So it means that energy in the function of the wavelength, that is the each wave having a definite wavelength has a definite value of the energy. So being a second order differential equation, the Schrodinger wave equation can have number of solution. So many of them being without any significance, but for some definite values of the total energy E, the solution will certainly have the significant value. So as we discussed, the value of the total energy for which the wave equation can have significant solution, this is called the eigenvalue. And these eigenvalue correspond to the discrete energy level of postulated by the Bohr's and postulated by Bohr. So it means that the existence of definite atom energy level in an atom has been directly proved by the Schrodinger wave equation. So which has given rise of the wave mechanical concept of the atom. The various values of the psi which have been derived from the wave equation corresponding to the definite value of the energy, and this is called the eigenvalues. Okay, these are called the eigenfunctions. So these are the some satisfactory values, or the we can say that the acceptable psi values. So So these are the eigenvalues and the eigenfunction. Now we know the some information about the eigenvalue and the eigenfunction. I have one important point that the psi does not have its significance, and the psi square is the probability of finding the electrons around the nucleus. That is called the psi square. So in this lecture we have discussed about the classical mechanics and the quantum mechanics and the dual nature of the electron, and the Schrodinger wave equation, the general information or the concept of the Schrodinger wave equation, and psi and the psi square. So now I stop my lecture, and for any query can contact with me. Thank you. पता नहीं